Hello, today we are going to talk about solving equations involving absolute value. You'll find this chapter 2, lesson 5 on pages 103 to 109. So let's get started. The first thing we're going to do is evaluate. Remember, that means we're substituting values into our expression. All right, and we're going to get a numerical answer. Okay, so this isn't an equation just yet. We're just going with expressions. So a problem you might see looks something like this. We'll have the absolute value of a minus 7, and then outside of that, plus 15. We want to find out what this value is when a is 5. All right. And if you remember from the last couple of years, absolute value makes negative numbers positive and does absolutely nothing to positive numbers. Okay. So again, it's just this number's distance from 0 is what an absolute value gives us. So anyway, what we do is we substitute 5 into a here. All right, and we get 5 minus 7. We're gonna handle that. And think of these as kind of like parentheses, but we don't distribute into them. So we do not use the distributive property with absolute values. Keep that in mind. All right. And then we get negative 2, and the absolute value of negative 2 is 2. So we simplify that. Remember, it makes negative numbers positive and does absolutely nothing to positive numbers. And then we add those two together and we get 17. All right. So what I'd like you to do is pause the video and give this one a shot. Remember, you're going to substitute 2 in for x, clean this up, and then 23 minus whatever that value ends up being. And it obviously is going to be a negative number. 3 minus 4 times 2 is going to be negative, so you'll have to apply the absolute value. So give this pause this video and give this problem a shot. All right, now, in example 2a, we are solving an absolute value equation, okay? And so what we kind of have to realize is that in order for this expression, 2x minus 1, to be 7, then this number, and you got to think of 2x minus 1 as just a number. Don't get all intimidated by the 2x minus 1. It's just a number that we don't know the value. Well, in order to get 7 out of an absolute value, the number could be 7, or it could be negative 7. Okay, so I want to say that one more time. If we kind of thought backwards, there are essentially 2 ways for this to work. Red should probably show up. If the absolute value is 7, because the absolute value of 7 is 7, or the absolute value is negative 7, which is also 7. Okay, so if this result was 7, it would kick out a 7, and if this result was negative 7, it would kick out a 7. So we got to figure out when this value here, 2x minus 1, is 7, or when it's negative 7. So you've got to split this up to solve it. And then notice when I split it up that the absolute value symbols go away. I just want to know when this number is 7 and when this number is negative 7. So I would solve this out. And I don't think I actually did that here, so I should probably, for at least a couple more PowerPoints, do the work for this. So that's 2x equals 8, and we can see hopefully that x equals 4. I divided both sides by 2. All right, and I can do the same thing here. I can add 1 to both sides, and I get 2x equals negative 6. And when I divide both sides by 2, I get x equals negative 3. And those are our 2 answers. Okay, so again, understanding what absolute value does, it doesn't do anything to positive numbers, and it makes negative numbers positive. Okay, the common mistake here is kids often change the sign here. You do not need to. You just got to change the sign of what it equals. Okay, and then maybe some of the tricks that we see in these are if the absolute value of something equals a negative number, that can't happen, so that's our no solution situation. If it equals, maybe it equals negative 5 or something like that. And then now for 2b, we want to isolate the absolute value first. So we don't want to make 2 equations here yet, because the only time it works is when the absolute value is isolated. So this 2 and this 5 are going to change what this 7 is. So we subtract 2 from both sides, and we get 5 times the absolute value of x equals 5. I'm going to divide both sides by 5. Oh, I missed that step. Sorry about that. So if I divide both sides by 5, I get the absolute value of x equals 1. So this number, in order to kick out a 1, could be 1, which is what we get here, and negative 1. Oh, just flew it in the wrong order. Sorry about that. And negative 1. So again, if x was 1, it would give me 1. And if x was negative 1, it would still give me that 1. Okay? Now, story problems. Ice cream should be stored at 5 degrees with an allowance for 5 degrees. Write and solve an equation to find the maximum and minimum temperatures at which ice cream should be stored. The midpoint of the high and low tolerances will be what you subtract from x, and inside the absolute value symbol. Okay? So, if we think about this, the midpoint of the high and low tolerance, so the high in this case, if it should be stored at 5, the high is 10, the low is 0, okay? In that case, the midpoint is 5, so this is the midpoint, and you subtract that from x inside the absolute value. The tolerance level, what you set your equation to, so our allowance is 5, so kind of the bad thing about this problem is that these numbers match, so it's hard to tell what, but I'll try to explain it. Okay, so this 5 here should be stored at 5. This is the midpoint of the high and low. Remember, the high would be 10, the low would be 0, and those are going to be the answers to the problem, but we're going to solve it. So this 5 is what's right here, and then the tolerance, the allowance, is this 5. Okay, probably make a note of that so you understand this is something you want to write down. And then we simply just solve it out. So I know that this value could be 5, or this value could be negative 5. That's what we get here. All right, and then I solve both of these. Add 5, I get 10. Add 5 to negative 5, I get 0. And those are my answers. And we got one more problem we want to look at. And that's writing an equation. All right, given a graph. And what we want to do first, the first thing we want to do is figure out what the middle of this is. Okay, in the middle of 17 and 27. So I guess one way to do is you kind of just check it off. So 1 there, 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 and it looks to be the middle is 22. Kind of missed there. All right, so that's our middle. All right, and that, again, the midpoint is what is being subtracted from x inside the absolute value symbol. And then our tolerance, our allowance is 1, 2, 3, 4, 5, and just to check over here, 1, 2, 3, 4, 5. So how much we can change from the midpoint is what we set our absolute value equation equal to. All right. Now again, this value could be 5, and that's right here, or x minus 22 could be negative 5. Again, no absolute value, and I did not change this sign. Okay. What happens is kids kind of memorize that I just changed the sign. They don't really understand why. And then when it comes time to a quiz or a test, they wonder what side should they be changing. Remember, it's this value could be 5. The absolute value of 5 is 5. This value, x minus 22, could be negative 5 because the absolute value of negative 5 is also 5. That's why there are two results to this equation. And then I'd add 22 to both sides and get 27. That's that guy right there. And I can add 22 to both sides and get 17, and that's that guy right there. So to kind of summarize this last one, find the midpoint. That was 22. That's what we're subtracting from x. And then your distance from your midpoint out to your blue dots here is what we set our absolute value equation to. These are the notes I'd be taking on this. Midpoint is what I'm subtracting from x. Distance to the blue dots is what I set my equation to, and then simply solve the equation. I hope this video helps, and I will see you guys next time.